Alright, take two. The first one didn't come out very well. Alright, this is to demonstrate how to remove a capacitor from a motherboard. Today we'll do this guy. It's already a little wobbly. You can tell it's seen better days. It's starting to tin out. I had done this guy right here in the previous, and let me flip the board over. Alright, the guy we're going to do is right here. The previous one was up here, and you can see there was a whole bunch more ground plane, although I guess this guy's nearly as bad. Now, I've already fired up the iron. It's about 700 Fahrenheit, figure 375 Celsius or so. It's a Hacko 936, so wattage I'm not entirely sure about. 20 to 40, but it's temperature controlled. And I got some solder. This is 0.025, 0.6 of a millimeter. So what I'm going to start by doing is I'm going to heat up the joint a little, flow some solder in. Now the goal here is to create a big enough gob that I can bridge all the way across to both sides. I'm going to rotate this around so that I can get under it with my left hand fairly easily. Oh man, that glares right in the middle of everything, isn't it? There we go. Alright, here's our leads for our capacitor. What I'm going to do is I'm going to start by bridging them over and kind of heating up the top. You hear that little tick? Now it's wobbling. And there's the bottom. I'm going to heat up the bottom. Now this is the one that's connected to the ground plane. Another potential problem is that this could be connected to the outer part of the foil on the capacitor, so the capacitor will start getting really hot. Make sure you keep this gentle. This should be mainly a pulling down motion. And off we go. Rocking it back and forth will definitely help. Now, a lot of these caps are stronger on top than on the bottom, so they might tin out at the top like that and start to dome, but the bottom will still be flat even though it's rubber. The other cap that was removed earlier, the bottom on it, you can see from the light, it's starting to dome out. The top's flat. It doesn't have a vent. Well, anyway, that's not what you wanted to know about. Surface mount caps are similar. You're just working from the top, and essentially you're putting pressure. You'll push against them one way while you're heating up underneath your finger. You have to be kind of careful you don't fry yourself. You also have to be very careful not to lift the pad. On surface mount, it'll be a lot more fragile than it will when you're dealing with a giant copper plane like this. You're not in danger of lifting the trace as much as you are just not having the heat. But it's more than just heat that does the job. The fact that you can heat a joint, I mean, it takes a very long time to melt all that out when you've got a ground plane connected. You add a little bit of solder, and what's already there is liquefied by the solder you add. Getting these cleaned out turns out to be the biggest pain in the butt. You can use solder wick. What I like to do is stand the board up so that it's vertical, heat it up from one side with the iron, and have the plunger on the other side ready to go. And when I see it liquefy, I trigger the plunger and it'll suck all of the solder right out of the hole from a through hole system. From a surface mount system, you can't beat solder wick. You just have to heat it up over the joint. It works the same for these. Let it move a little. Often you'll need to work both sides. I won't bother trying to stand this up, but see how it's sticking? That's a function of that big ground plane sucking up all the heat. If you ever wind up in a position like this and you can't seem to get it free, Do the same thing you do for a capacitor. Flow some solder onto it, pop it right off. Alright, I hope that helps.